Good morning, all of you. Again, welcome all of you to my video on Structural Design 1. Now, today, the first topic is on the design of staircase. In the last three modules, we have studied the design of slabs, beams, etc. Now, what are the design aspects in the design of a staircase? We'll see one question, one design problem. A room is given to design a dog-legged staircase. A dog-legged staircase for a room of size 2.8 meter by 5.8 meters. And the distance, vertical distance between floors is given as 3.6 meters. Width of flight 1.25 meter. Live load is given as 20 Newton per mm squared. The Fy value 450 Newton per mm squared and the thickness of wall 230 mm. These are the data given. As per this data, to design a staircase, a log-legged staircase. Okay. For that, first of all, the first step is to proportionate the stair. That means the number of steps to be designed. For that, from the given criteria, to proportionate, the room size is given. It is 5.8 meter, this one 2.8 meter. Okay, the two measurements of the room. Now, the vertical distance between the floors is given as 3.6 meters. Therefore, height of one flight will be equal to how much? What is height of one flight? The height from the floor to the landing. Then from the landing to the roof again. So the total height is 3.6. Therefore, one flight will be 3.6 by 2 equal to 1.8 meters. That is the height from the floor to the landing, 1.8 meters. Now for this height 1.8 meters, when we decide the number of steps or risers first, you know what's meant by the rise and tread? Rise is the vertical distance, the vertical, and the tread is the horizontal distance of a step, isn't it? So to find out this number of rises, divide this height 1.8 meter by the rise value. What is the rise value? It is varies from 150 to 190 mm. We are assuming it as 150 mm, and the tread is equal to 300 mm. The tread also may vary from 250 to 300 depending upon the type of the building. So when you design any building, according to the type of the building, you can decide the rise and tread for a step. Okay, so here when we assume it as 150 and 300, then number of rises will be equal to 1.8 divided by 150, 1.8 meters divided by 0.15 meters equal to 12 numbers. So number of rises 12, 1, 2, 3, 4 like that, 12. Therefore, number of treads, that means the horizontal distance will be equal to how much? Minus 1. 12 minus 1 is equal to 11 numbers. So 11 numbers of treads. See here, 1, 2, 3, 4 to 11 for one flight, then 12 to 22 for the second flight, and this is the landing. Is it okay? Now, the number of treads is equal to 11. Therefore, what is for 11 treads? The total length will be equal to 11 into this value. 11 into 300 is equal to 3300 mm or 3.3 meters. So the total length of treads will be equal to 11 into 300, 3.3 meters. That means, see here, this is 3.3. One flight 300 into 11, 3.3 meters. Therefore, width of landing will be equal to how much? Total 5.8 minus 3.3 divided by 2. So 1.25, 1.25. On each side, it is 1.25. Here also, it is 1.25, 1.25. So this width will be equal to 0.3 meters. Total 2.8. Is it okay? So that is the first step. Proportioning of stairs. Proportioning of stairs means find out the number of steps and width of landing. Is it okay? Now, the next step After proportionating the steps or the stair, the second step is to find out the effective span. As in the case of beam and slab, the effective span is the center to center distance between the supports. Here the thickness of support or thickness of wall is given as 230 mm. Therefore, effective span LE will be equal to 5.8 plus 0.23. One wall thickness, half wall thickness plus half wall thickness means one wall thickness 0.23 equal to 6.03 meters. That is the effective span, right? Once we get the effective span, then the next one is the thickness of the waist slab. There will be a slab here below this step, isn't it? That is known as the waist slab. So the thickness of the waist slab or the overall depth, effective depth and overall depth you can find out as usual. What is the thickness of waist slab or the overall depth? How can we find out? As per the stiffness proportionality, the stiffness criteria, LE by D, span by depth ratio, isn't it? LE by D is equal to 20 to 25. As per the code provisions, we are assuming it as 25. LE by D is equal to 25. From that, D will be equal to LE by 25 or 6.03 by 25 equal to 242.1 mm, say 250 mm. So we are taking the value of effective depth of the slab is equal to 242.1 or 250 mm approximately, 250. Once we get the effective depth, we can find out the overall depth. Overall depth of the waist slab here below the steps, that's equal to 250 plus 30, where 30 is the effective cover from the bottom of the slab to the center of the reinforcement, isn't it? That is 30. So 250 plus 30 is equal to 280 mm or 0.28 meters is the thickness of the waist slab or the overall depth of the waist slab. Understood? So this is a question asked for the last exam also, April 2019 I think, the same question, to design a dog-legged staircase from the following data. So these are the data given. So as per this data, the vertical height will be given, the floor to floor height will be given to you, and the room size, width of flight, then live load, the property of steel Fy 415 and the wall thickness, isn't it? The wall thickness will be given, isn't it? So as per this data, to design a staircase, first decide the number of steps from the proportionality, taking the height of the flight and deciding the tread and rise, get number of rise and number of treads, and from that the total width of the treads. Okay, here we got it as 11 in one flight and 11 in the other flight, total 22. And after that, get the effective span and then the effective depth and overall depth of the waist slab. Is it okay? So the next video will continue the same design. After this, we have to analyze the loads now. What are the loads? Dead load, live load and floor finish. Calculate the three loads, add together to get the total load and multiply with the partial safety factor WU, and once we get the value of WU, find out the bending moment, WL squared by 8 bending moment, and after that, what is it? Designing of steel reinforcement AST and distribution steel. So that process, that steps we'll do in the next video from step 4 onwards, right? I think it's clear to you. Okay, thank you.